All right, in 4.3, we're dealing with the exact same skills that we developed in 4.2, but now we're applying them to fractions. So inside the problems that we worked with, you could have fractions, okay? So essentially, your notes are just the same as before. If you need to look back at them, you may. But we go right into our example. Example 1, solving equations involving one fraction, okay? A, 6 equals 1/3 of 8 plus x. Okay, so I'm looking at this problem. I'm thinking, what can I do? I can't group the terms together inside the brackets. I have a constant and a variable term. Can't do that. We know that we could apply the distributive property, right? I could multiply this by 1/3 and this by 1/3. That's a good strategy. You will be able to work that out and get the right answer, but you'll be working with fractions all the way down. Can anyone think of a way that in one step I can keep the equation true, means I have to do the same thing to both sides, and I can get rid of that fraction?
Times it by 1/3.
No.
By 3/1. Times it by 3/1.
Okay. Ready? A little note here. Instead of using the distributive property, instead of using the distributive property to remove brackets, multiply both sides by 3 to remove the fraction.
Every time by 3.
Nope, only by 3 because it's 1/3 here. So if I rewrite this, and remember, if I'm doing something to the right, I have to do it to the left. So we're going to have 3 times on this side. And we're going to have 3 times on this side. All right. Now we can simplify this, right?
Hey, why did we put the 1/3 back? I thought we got rid of it.
Nope, I haven't done anything yet. I've just shown that I'm going to multiply both sides by 3. So I'm going to multiply, I have this, and I'm going to multiply the whole thing by 3, and I have this, and I'm going to multiply that whole thing by 3. So that's all I've noted, that we're going to multiply by 3, and we're going to multiply by 3. Okay? So now when we actually finish that out, on the left side, 3 times 6 is just 18. And over here, you're right, we have an invisible over 1. 3 is 3 over 1, which cancels out this whole fraction, right? This becomes 3 over 3, which is just 1, which just leaves us with what was inside the bracket, 8 plus x.
So
Okay?
every time you do that, it cancels out each other, basically.
It cancels out each other and becomes 1.
What happens if the 1/3 was actually 1/5?
Then what would we do?
You still put
Times it
3?
by 3.
We would multiply by 5.
Okay, so
And then do 1.
It would still be
x
1. It would
equals
eliminate the brackets either way. Okay, let's just, last question, and then we'll follow this example through and we'll see more examples.
When, after you times it, like 3 times 1 and then 1 times 3, would it be 1?
It is 1, yep. And 1 times anything is just that thing.
Oh.
Right? 1x is x. 1 Sammy is Sammy. 8 plus x times 1 is just 8 plus x. Good? All right, what's our next step?
Minus 8 by reduce to 18.
Good. Subtract 8 from both sides. And see if you can get that final answer. Good? All right. So, it's the same steps as before, but instead of distributing, we got rid of that fraction right away. Now, later on in today's lesson, I think, we're going to get into, what happens if you have two fractions and you have to do the same thing to both sides. It gets a little bit tricky. But for now, stick with this. Instead of using distributive property, multiply by the number that will get rid of your fraction. And then do that same thing to both sides. B. Looks tricky, doesn't it? 3 times y minus 5 over 4 equals 7. All right, take your time. Don't say anything out loud. What do you think you're going to do in order to make this a little bit easier? Right now we have a fraction, right? The whole side over here is a fraction, and we want to get rid of that fraction. Multiply both sides by, Ronnie?
4.
Nice. Can everyone see that?
Wouldn't you use the
Nope.
distributive property for like 3 times y?
Don't have to. We're getting rid of our fraction first. Okay? So we're going to do times 4 over here, times 4 over here.
Wait, is it always the side of which the bottom fraction is?
The fraction, the denominator, determines what you're going to multiply by. 4 is the only number in the whole world that will get, well, that's not true. I could use 8 to get rid of the fraction as well, but that would double the top number. Not worth talking about. Look at the denominator. It's being, this group right here is being divided by 4, so I'm going to multiply it by 4. What does that do? Cancels those guys out. Okay? So now in my next step, all I have is the 3 times y minus 5. And on the right side, 7 times 4 is 28. I've done the same thing to both sides, so I know my scale is still balanced.
And then you do the 3 times.
Now what can I do?
Distributive property.
3 times y.
No.
Yeah.
Distributive property. Minus 3.
There's 2 ways to do it.
No, you
You minus 5 from 28 and then divide 3.
Well, it's not, doesn't have a value of 5, right? It has a value of 3 times negative 5.
Did you just
Don't you do that?
So I'm going to use distributive property. Okay, so now this looks exactly what we did yesterday.
Boom, and then the other one. Yeah.
So we have 3 y's. We have negative 15 equals 28. Now what?
positive 15 plus
Yeah. Good. Add 15, and then what's our last step going to be?
Apply, distribute.
What's my last step going to be?
Divide.
Right.
Both sides by
3.
3. Alright, so we're going to add 15, which gives us 3y on the left and 43 on the right. And then we're going to divide both sides by 3, which is going to give us y on the left, and it's going to equal simply 43 over 3.
No, we're not.
Hey, because you can't simplify.
Yeah.
Or-
Because then it gives you
You could-
decimals that are-
You could write it as a decimal, but it would be a repeating decimal. It would be a on and on and on, a non-terminating decimal. So we just leave it as a fraction. It's an irrational number.
Did you have it as a mixed
record
fraction?
this one?
the bottom.
All right, in example 2, it's solving, but this time we have more than one fraction. So we're going to solve k plus 2 over 3 on the left of the equal sign and k minus 4 over 5
You make it
on the
the same
right
line.
of the equal sign. Now, how can we figure this out with two fractions? Give you a few seconds to think about it. Jaden, what's your thought?
Could you add the 2 tops and the 2 bottoms together to make one fraction?
No.
I can do that, but not as it is right now. Why can't I do that now? Why can't I just move this whole fraction to the other side and set it equal to 0?
Is there a need to
Equal the
Have
balance.
common denominators.
I would need common denominators. We're on the right track.
Oh, that's
Jacob!
I thought about that. You make both 15.
Ah, okay.
Nice, Jacob.
So-
Last time I was-
No, I didn't think you were
I heard
stupid.
someone laugh.
Let's find the common denominator, okay?
I just
Find a common denominator. Okay, so we have 3 and 5. So for 3, our multiples are 6, 9, 12, 15. I could keep going, but we know we don't need to. For 5, the multiples are 5, 10, 15 up. LCD equals
You have to do this
15.
in your question. If you really know.
If you already know this, then no, you don't need to show it. But now watch what happens, okay? You're right. I could multiply top and bottom on this side. We're talking about rules that we don't know. I could keep this, the value of this, the exact same by doing the same thing to the numerator and the denominator. So one rule I can do is I can actually just multiply top and bottom by 5 to get a denominator of 15, and I won't have changed the value of this fraction at all.
What?
And then I could multiply top and bottom by 3, and I wouldn't change the value of that fraction at all, and it would have a denominator of 15.
You just said.
It's not what we're going to do, though, because it's not what we've learned in the last couple days. So just ignore that. Look at what we're going to do. We found the lowest common denominator, so I'm going to multiply both sides by the lowest common denominator. Okay?
Oh, yeah.
Oh,
Oh,
sadly.
yeah, yeah.
Multiply both sides by the common denominator. Now, look at what happens over here. I have this group, so k plus 2, is being divided by 3 and multiplied by 15.
That just takes out the 3.
It takes out the 3, and the 15 turns into
Nothing.
a
How does it turn into
a 5.
How does it take
So look.
3?
I could rewrite
Just
this.
knocks them
Let
out
me
like
rewrite.
this.
Let me
K
rewrite
over
this a
right.
different way. Okay. We have k plus. I'm not going to use that color marker. We have k plus 2. This step is not necessary, but it might help you to see it better. So we have k plus 2 as a group. Okay. That group is being divided by 3, but that group is also being multiplied by 15. Okay.
So do you, like,
Same
do
thing
you
on
want-
this side.
How does the 3 go
We have
away?
k minus 4. It hasn't gone away yet, so just slow down. It's being divided by 5 and multiplied by 15. Okay, so now look at what we have. We have 15 of these, but we're going to split it into 3 groups. So how many of these do we actually have?
5.
We have 5 of them, right? 15 divided by 3 is 5. So if I have k plus 2 15 times, and then I split it into 3 groups, the only thing that's going to be left in each group is 5k plus 2s, 5k plus 2s,
I don't get that.
5k plus 2s.
There's 3 of them.
Okay?
Can we just say that we had 5?
So,
Did we just
I
say
thought
we
we had
knocked out
test
the
common
3?
denominator.
slow down. Slow down. Slow down. We're not going to have any denominators when we're done this. That's the beauty of it. This lesson, we're getting rid of our fractions. So
I
this.
know we're doing. I know.
So now look, we have 15 divided by 3, which he becomes a 1, he becomes a 5.
That's 5.
And over here, what's going to happen over here?
Oh, I get
Wait,
it
what'd
now.
you
It's
do with
gonna
the
be
15 and 3?
three.
Did you divide them?
The
One.
5 disappears,
And it's gonna be 3.
cancels out, and we have 3 left at the top. Okay?
So now
And
you
then
know-
we use the distributive property.
Oh yeah. So now let's
Yeah,
rewrite what we have.
Yeah.
Hey.
Ooh, you know you're gonna have so much questions tomorrow.
Okay. And we're going to write the step beside it. Multiply. This is what we already did. Multiply both sides by LCD, lowest common denominator. That was 15 in this case. To do what? What did we do? We eliminated Eliminate. To eliminate what?
The fraction.
The fractions. To eliminate the fractions. We don't need to worry about a lowest common denominator on both sides, our common denominator on both sides, because we don't have a denominator anymore. Good. And Sam, my next step.
Now you have to 5 divided by.
Apply this one.
Oh, apply just, yeah.
Okay, go ahead and do it, and then check the board to see if you've done it right. If you've checked that step, then go ahead and finish it out. Solve it.
Wait. Can we add 5k to 3k and 10 to 12?
No, sir.
You can cancel them out.
You can.
Slow down. Your goal is to get all the variables on one side and all the constants on the other. But look at what happens if you were to add 5k to this side, you'd have 10k.
No.
And over here, you'd have 8k.
Yeah.
So that doesn't help.
Wait, what?
So what are you
No,
actually...
he's saying
You
like add the 5
3
plus
and 5
3k.
together.
5k
There
plus
are-
Like
3k.
terms.
If you do something to one side of the equation, you have to do the exact same thing to the other side. Okay?
How'd you get 2?
I got 2.
How'd you get 2?
I got 2.
Minus 3.
You go -3 and then 5.
What?
Oh,
Wait.
okay.
Try to figure out how it happened.
I don't know.
You can only ever do the same thing to both sides. So what step did I not write?
I got it.
I did not write this.
Yeah, he did not write the division problem.
And I did not write this.
Now get rid of the
K
3k.
equals-
And I did not write this.
No.
-3k. 5 minus 3 is 2.
Oh, okay, I did that wrong.
Okay? K equals... Alright, example 2b. It's there before you. You have 1/3 times the group 2x minus 5 on the left side of the equal sign. And on the right side of the equation, you have 3/4 of the group x minus 2. Now, in previous lessons, we would have applied the distributive property right away. But we're not going to do that this time because our goal is to eliminate the fraction by finding a common denominator, a lowest common denominator. Okay? So we're going to find LCD between what two numbers? The lowest
3 and 4.
3 and 4. Okay? So you got 3 here
Those are the fractions.
and 4 here.
Good job, Maddie. Good job.
Also a fraction.
Let's go, Maddie.
Okay? And we could do this the same way. We could go 6, 9, 12, 8, 12. We could also use prime factorization. So I'm going to show that as well. So the prime factorization of 3 is just 3 times 1. Prime factorization of 4 is just 2 times 2. So the lowest common denominator, I guess times 1 if you wanted to do the times 1, but you don't have to. So the lowest common denominator here is 3 times 2 times 2, which is 12.
Stick with the
Maybe
LCD.
I
Okay.
would just that complicated it.
So all we've discovered here is that we need to do what?
Find the LCD.
We did that already.
And now put
Apply
that in
it.
the bracket. Apply.
Multiply both sides by LCD, which is 12. Okay, go ahead and try that part. I'll do it slowly up here, but you can check the board as you're going. Try to do it as much as you can on your own.
I get it, but it's just so important.
Ooh, that's
You
right.
divide it, remember, because you divide 12 like
Hey, Mr. V,
Yeah, but
I
when you
did
get the
I
one
did
in
that
here,
all.
I need it 9.
You got Jake. Well,
Okay, so here's how we got that number 9. 12 is 12 over 1. Multiplying fractions is top times top, bottom times bottom. So we could do 12 times 3, 36, divided by 4, that's 9. Another way to think about it is we could do 12 divided by 4, or reduce that to 3 over 1. And now we just have 3 times 3 over 1 is 9. Okay? The next step,
distributive property.
thank you, apply distributive property. So I'm going to do it without the arrows this time. We've got 8x minus 20. Again, you should be trying to work ahead of me, faster than me, so that you're essentially just checking your answers here. And we have 9x minus 18. Now what?
Don't.
I
do-
say
you
we
do
work
the
from
minus
right
8.
to left.
No, because if you do negative 9x
This is
minus
where I
8,
always.
it's
Yeah.
Okay.
going to be negative
So
x.
we'd like to keep it, in order to keep it positive, we're going to bring our variable to the right.
Yeah.
Yeah.
Okay? So we're going to subtract 8x from both sides. And we're going to add 18 to both sides. That's going to keep our variable positive, but our answer is still going to be negative, which that's okay. X equals negative 2.
Bam.
Kabam.
Mr. V, I found a different way.
Okay, ladies and gents, we're also asked to check if our answer is correct in this one. So we're going to check, and in order to check, all we have to do is take our original equation, which is up here, and everywhere we see an x, we're going to sub in negative 2. Now look at how you do that very carefully, okay? Please watch the first time, and then you can follow through on your own. So here we go. We've got 2 times x, but instead of x, we're going to write negative 2. Now I put it in brackets to show that it's 2 times x. So I have 2 times negative 2. I can't have 2 minus 2. That's not the same thing. Okay? Now I finish off what's in the bracket. Go to my right side of my equation. Same thing. I'm going to put a negative 2 in there. I can do it in a bracket. It doesn't really matter on this side because it's just subtraction within that bracket. Okay, so you could drop those brackets. That's okay. On the left side, we're dealing with bedmass, so we've got brackets first, and inside the bracket, I have multiplication and subtraction. I'm going to do the multiplication first. So we've got 1/3 bracket. 2 times negative 2 is negative 4 minus 5. On the right side, we're a step ahead. We're going to do negative 2 minus 2, which is 0. Oh boy. No, it's not. It's minus 4. Whew, that was close. Follow through on the left side. Inside the bracket, we have negative 4 minus 5, which is negative 9. On the right side, we're a step ahead. We've got 3 being divided by positive 4 and then multiplied by negative 4. So the value of the 4, the number part, is going to cancel out, but we have 3 factors and one of them is negative. So what's my answer going to be, positive or negative? It's going to be negative, and the 3 is going to be left standing by itself after it gets divided by 4 and multiplied by 4. And then our last step on the left side, 1/3 of negative 9
Is 3.
with the negative sign, right? Negative 3. And did it work?
No.
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 Is the left side equal to the right side?
Oh yeah.
Yeah, we're just checking, right? We're not trying to get negative 2 again.
Okay, can you
We
explain?
subbed in negative 2 into the
Explain
original.
fraction part with 3 over 4.
Yeah, I was gonna
minus 4.
This part?
Yeah.
We could stretch this out, and it could be like 3 over 1 times 1 over 4 times negative 4 over 1. Okay, that's all the parts of it. So, or it could look like this. Well, let's do this out first. So this would give us negative 12 over 4,
Divided by is negative.
which equals negative 3. Or we could look at it this way. You could say, okay, if 3 is being multiplied by negative 4, I could actually just bump that guy into the numerator and divide by 4, which would give me negative 12 over 4 which would give me -3.
Yeah.
Or you could cancel these guys out and go straight to -3,
Yeah.
making sure you keep the negative sign. Okay. All right, your practice problems for 4.3 are found on page 226, just number 25. All right, this is 4.3 bonus example. Please pay attention. If you have space somewhere, you can write it. If not, flip to the very back of your booklet or something like that. Okay? This is an example where we have a fraction on both sides, and we have a group. So we have x minus 3. I consider that a group because that whole group is being divided by 5. And on the right side of the equation, you have x plus 1, all being divided by 4. Now, what's the best? How am I going to get rid of these fractions?
I just don't know.
Like lowest common denominator.
I'm going to find the lowest common denominator. So, find the LCD between 4 and 5. Here we've got 8, 12. Yeah, or you can multiply them together. Okay, 8, 12, 16, 20. Here we have 5, 10, 15, 20. There we go. So, I'm going to multiply both sides by 20. I haven't changed the balance of the scale here. I'm doing this exact same thing to both sides. Okay? Now, what am I going to be left with on the left side?
4 on the
That's right. So 20 divided by 5 is 4. So I'm going to have 4
x minus 3
times that group. Remember to keep x minus 3 as a group. Okay?
This is where I get lost. This next step.
The next step we should be familiar with.
I don't know why.
On the right-hand side,
It's going to be 5.
Why is it gonna be 5?
Oh, I
20
get
divided
it.
by 4 is
Get
5.
it now,
Yeah.
Jenna?
Yeah, finally.
okay, 20 divided by 4 is 5.
What about the left side?
20 divided by 5 is 4.
Okay.
Okay?
I get it.
Jaden, next step.
You do 4, so that it's 4x and minus 12, or negative 12.
Good.
And then 5x plus 5.
Nice. Okay, this is a place where people often make a mistake. You'll write 5x plus 1. Nah. Distribution. 5x times plus 5. Okay? If you need to keep drawing your arrows, keep drawing your arrows. Okay? Now what? Jacob.
Wait 1 second. Hey, what are we doing now?
That's
do you
what.
want me to do?
Yep, exactly.
What do you want me to do?
Mm-hmm, yep.
You're getting played.
Tell me what's next.
We gotta find out, or gotta get x all on one side.
Collect our variable term all on one side. Yep. Which way would you like to move it?
Yeah. 4.
To the right.
Yeah.
So we're going to
Divide by 4.
Slide where?
Subtract by 4.
subtract 4x from both sides.
But would it be 1x or just normal x?
We're subtracting 4 x's from both sides.
And
If
then
you're
negative
asking
12
what's going to
divide.
be, and
Is
Oh.
Add
No,
12.
negative.
Add 12.
Yeah.
if we moved our variables on the
No, it's
right,
negative
we're gonna
12.
bring our
Add 12
guys.
to negative 12.
No.
Slow down.
Slow down.
Look,
Yes.
Yeah, that's
Oh,
all we're doing.
Yes.
What did you do?
Yeah.
if our variables are going to be on the right, then we want everything else on the left.
Yeah, that's, yeah.
Woo!
Go down.
Maybe I